Good evening. Long time. I'm not sure if you're still doing linear programming, but we are doing linear programming today. Hopefully one of you has this in one of their homework or in one of their tests or exam. So we're just going to do an example. So we are given the statement. They say to meet the requirements of a specialized diet, meal is prepared by mixing two types of cereal, Vuga and Molo. The mixture must contain X packets of Vuga cereal and Y packets of Molo cereal. The meal requires at least 15 grams of protein and at least 72 grams of carbohydrates. Each packet of Vuga cereal contains 4 grams of protein and 16 grams of carbohydrates. Each packet of Molo cereal contains 3 grams of protein and 24 grams of carbohydrates. There are at most 5 packets of cereal available. Then just a description. The feasible region is an area that satisfies all the possible solutions. So let's just analyze what is given. So they said to meet the requirements of the specialized diet is prepared by mixing two types of cereal, Vuga and Molo. And they said Vuga is X and cereal is Y packet. So we've got Vuga, which is expressed as X, and we've got Molo, which is expressed as Y. So they say the meal requires at least 15 grams of protein and at least 72 grams of carbohydrates. Then when you go further, each packet of Vuga contains 4 grams of protein and 16 grams of carbohydrates. And also Molo contains 3 grams of protein and 24 grams of carbohydrates. So we've got let's say we've got protein and then we've got carbohydrates. Then we've got our Vuga, which is X, we've got Molo, which is Y. Protein, they said proteins for Vuga is 4 grams and protein for Molo is 3 grams. So we've got 4 here and we've got 3 grams for protein. Then carbohydrates content, we've got 16 for Vuga and 24 for Molo. So we've got 16 and 24, right? Then what else is given? There are at most 5 packets of cereal available. So when you add Vuga to Molo, it must be at most 5 packets. It can't be less than, okay, it must be at most 5 packets, which is actually it's less. It can't be more than 5. So at most is less or equals to 5 packets. They can't go beyond 5. So it's less or equals to 5. Then again, when we go back, they said the meal requires at least 15 grams of protein and 72 grams of carbohydrates. So for proteins, the total must be at least 15 grams for the carbohydrates. So we're going to have 4x plus 3y is at least 15 grams. And at least is more than. So we're going to have 4 VOGA, which is x, plus 3 molo, which is y. It must be more or equals to 15 grams. And then the other statement was, and at least 72 grams of carbohydrates. So when you add the content of VOGA and molo carbohydrates, it must be at least 72 grams. So we've got 16 VOGA plus 24 molo must be greater or equals to 72. So that's how you analyze the given data. So the first question they say write down the constraint inequalities. We have already done that. So we've got x plus y is less or equals to 5. For x plus 3y is greater or equals to 15. And then we've got 16x plus 24y is greater or equals to 72. So those are our inequalities. Then the next point is now show a feasible region. So for you to show a feasible region, you need to actually graph these inequalities. Thereafter, then you shade the region that satisfies all these inequalities. All these equations satisfy all the solution, where actually that area where there is a solution for all this is applicable for all these inequalities, or is true for all the inequalities. So if you look at this, the inequalities, they are more like anyway equations of line. So we're just gonna, and is x, y coordinates. So if we're looking for x, we put y 0. So let's start with the first one. If x is 0 on this first, on the equation 1, let me give them numbers. This is equation 1. This is equation 2. This is equation 3. So from equation 1, if y is 0, x is 5. So this is our number line. 1, 2, 3, 4, 5, 6. So we said from equation 1, if y is 0, x will be 5. So here we are on the number line. That's the x coordinate. The y coordinate, if x is 0, then y is, it's 5 also. So we're gonna have y 5 there. Then we can draw our graph. That's our first graph. The second one, from, okay, so if x is 0, this is a 4. If x is 0, we start with x-intercept. If y is 0, therefore x will be 15 divided by 4. So 15 divided by 4, let me use a calculator. 15 divided by 4 is 3.75. So if y is 0 from equation 2, x is 3.75. So x is 3.75. This is 3.5, 3.75. It's somewhere here. Then if x is 0 from the very same equation, so y-intercept, x is 0. If we put x to be 0, then our y will be 15 divided by 3, which is 5. So there is our y-intercept. So then let's draw the graph between these 2 points. It's 5 and 3.75. So that's our second graph. Then from the third equation, x-intercept, y is 0. So if y is 0, then x will be 72 divided by 16. 72 divided by 16, which is giving me 4.5. So which means x is 4.5. 4.5 will be here. Then if the y-intercept, if x is 0, y will be 72 divided by 24. 72 divided by 24, which is 3. So y will be 3. Then let's graph it. So now there we go. Then we need to show the feasible region. So here's my ruler. So let's show the feasible region. So the feasible region is the region where actually it satisfies all these inequalities. So from equation 1, this is the graph where it's cutting at 5 and 5, right? There is the graph for the equation 1. They say x plus y is satisfied, it must be less or equals to 5. So it's actually it's below this graph. There is the graph. Then if we look at equation 2, the graph for equation 2, it was this one. The solution must be above this graph. So 4x plus 3y is above 15. So the equation, the solution is above this. So here we are below this graph. Then on this equation, we are above this line. Then on the last equation, which is 16x plus 24y, this is the graph. And then even for that one, the solution lies above this graph because it's greater than that. Therefore, our feasible region actually is within this area. Sorry, not here. Within this area. That is our feasible region. So we can name the points at the feasible region. So we can have A here, and we have B at this point. Oh, sorry, not here. At the feasible region. So we've got B here. It's just, sorry for the cluttering now. It's not that visible. Then C, point C there, and point D at this point. So we've got point A, point B, point C, point D. Those are the points on our feasible region. Okay, so the next question that will help us in the next question. Then the next question they ask this, they telling us if Voga cereals cost 6 rand per packet, and Molo cereal also costs 6 rand per packet. Use the graph to determine how many packets of each cereal must be used so that the total cost for the mixture is minimum. So we're gonna use the profit equation. The profit for this is actually, they say, is 6 Voga cereal, which is 6x, plus 6y, which is 6 Molo cereals and 6 Voga cereals. So that's the profit equation. So if you want to know where the total cost for the mixture is minimum, we have to replace all the coordinates of this region into this equation and find the one that gives us a minimum profit or a minimum cost. So we've got point D. Point D is 0 and 5. X is 0 at this point and Y is 5. And then point A it's actually 3 and 1. This is not up to scale. So point A is 3 and 1. And then point B is 4.5 and 0. 4.5 and 0. And then point C is 5 and 0. So we've got point A, which was 0 and 5, and point B, no, Point A is 3 and 1. 3 and 1. Point B is 4.5 and 0. 4.5 and 0. Point C, 5 and 0. Point C is 5 and 0. Then point D, 0 and 5. Okay. Point D is 0 and 5. So what is our profit? We know our profit is 6x plus 6y. So now we're going to replace the coordinates to get the profit value. So if x is 3, so 6 into 3 plus 6 into 1. Then our profit is 18 plus 6. Profit is 24. Then here, 6 into 4.5 plus 6 into 0, which is equals to 6 by 4.5. 6 by 4.5 is 20. 27. Then profit here, 6 into 5 plus 6 into 0, which is 30. And then profit here is 6 into 0 plus 6 into 5, which is 0. Already we can see the minimum profit is 24. And they were asking a question, how many packets, use the graph to determine how many packets of each cereal must be used so that the total cost for the mixture is a minimum. So how many packets of X, how many packets of Y, how many packets of Voga cereal, and how many packets of Molo cereal. So we have determined the minimum cost is 24. Therefore, it means it's actually 3 packets of Voga cereal and 1 packet of Molo cereal. That is giving us the minimum profit. The next question, which is the last question, they say use the graph to determine how many packets of each cereal must be used so that the total cost for the mixtures is maximum. So already from the previous calculation, you can see the maximum profit is 30. So, and 30, the maximum profit, we're getting it at 2 points. When the Voga packet is 5 and 0 packets of Molo, or when it's 0 packets of Voga and 5 packets of Molo. So it's actually, that was at point A, and this is, the maximum is at point C and at point D, where we've got 5 packets of Voga cereal and 0 packets of Molo, and also is maximum where we've got 0 packets of Voga cereal and 5 packets of Molo. So that is linear programming in short. If you need any further information or any questions, you are welcome to contact me. You can send me a messenger or comment on the post, then we can take it from there. Thank you. Enjoy your weekend.